Now we have understood this concept already. Okay, this as we were going through the circuit, we have understood the concept of electrical potential. But just let's revisit it. As we saw in our jar battery, we had created a mechanism for moving the charges from one side of the battery to another. So that's what we had done. And as we were moving the positive charge from the cathode towards the anode, we called that this we had to do some work, and we call this work EMF, or electromotive force. That's what we called it. Now the same electromotive force is available in the circuit, right? When the battery is connected to the circuit across the two terminals of the battery, the same electromotive force is available externally as a voltage. So this is the voltage which is written on the battery as 1.5 volt. This is an example of a 9 volt battery. The EMF inside the battery gives rise to the voltage or potential difference outside the battery, which drives the electric current in the circuit. This is very similar to the potential that you would get, potential energy that you get when you climb up the hill, right? During your climb uphill, you are spending the extra energy to gain, and this energy is converted to potential energy. Okay, this extra work done that you are doing climbing up the hill, the extra energy that you are putting in doing the work gets converted to electrical energy. On your ride downhill, you don't have to put so much effort because now you can use the extra potential energy that you already have. So similarly, in the battery also, the energy given by the battery is we can use it to drive and do work around in the electrical circuit. Now, of course, the voltage available outside the battery and the EMF, they are measured in a unit called volts. It has been given after an Italian scientist, Alessandro Volta. Okay, and he was actually the inventor of batteries, and that's why we have given him credit and given the units of the potential as volts. Now the next important thing inside the electrical circuit is, of course, the flow of current, right? The flow of electrons. The flow of electrons across any cross section of the electrical circuit is known as electric current, the rate of flow. Okay. Electric current is measured in units called ampere, and they are actually base SI units. If you have studied from our past lectures, they are base SI units, and they have been named after a French scientist, André Marie Ampere, who actually was a very talented scientist. Inventor actually. He invented a number of things, and he improved upon things like, for example, electrical telegraph. So of course he was important. And that's why we have a unit named after him. The next important concept is the concept of electrical resistance. Okay, like I told you, all the material that we see around us, okay, all the normal day material, normal wires and switches and all of those things, as the electrical current flows through them, they offer some resistance to the flow of this electric current. They try to stop it. Okay, and this is what is known as electrical resistance. All the materials have it. Okay, all the normal materials have it, and this electrical resistance is a property of the material itself, and it is measured in units called ohm, ohm. They are named after German physicist George Simon Ohm,